Alright guys, this tutorial is for the 9-8 Factoring by Grouping number 1 worksheet, which you should have in front of you. The first thing, I just want to remind you what the word factor means. And yesterday we talked a little bit about when you're factoring out that GCF, your final answer ended up being some type of monomial times either a binomial or a trinomial. But either way that you think of it, it's some polynomial times another polynomial. So to factor an expression, you are writing it as a product, which means multiplication, a product of polynomials. And remember, a polynomial includes monomials, binomials, and so on. So when I ask you to factor something, you're looking to write it as a product of polynomials. So let's review. How would you factor the expression 3y minus xy? Well, we need to look for the GCF of both of those. I can see that they each have a y in common, and that's the only thing. So our GCF is y. That means y gets placed on the outside. We factor that out. And since we started with a binomial, we should have a binomial inside these parentheses here. So that first term, y times what, gets us 3y. That would be a 3 here. And the second term, y times what, is minus xy. That's going to be a minus x. So this is the final factored form of that original polynomial. Now, what we're getting into next is going to be just a little bit more complex in the fact that sometimes the GCF is a binomial instead of a monomial. So far, we've only had monomial GCFs. Okay, so sometimes it can be a binomial. Right here, this is a monomial. Why? That's a monomial. And so far, that's all we've dealt with. So today, we're going to be looking at binomial GCFs. So let's look at this expression. This is a little bit different, okay? And I'm going to kind of refer to these in different sections. But hopefully you can see right now that we have, let's see if I can get a highlighter here. I'll just use this. We have two different sections of this expression. We have the 3 times the x plus 2, and then we have minus the x times x plus 2. And hopefully you can see that each of these have an x plus 2 in common. So it turns out in this case, our GCF is actually the x plus 2. There's nothing else that they each have in common. It's not like each section has a 3 or each section has an x by itself, but they each have this x plus 2 right here. So that's going to be our GCF. Now, just like before, we're going to put the GCF on the outside, but since it's a binomial, it's going to stay in parentheses here. And now I want to talk about what's left over. So what's going to go in these parentheses here? Well, we had two different sections. We had this section here, right? And then we also had this section over here. So let's talk about if I took the x plus 2 out of this section, what's still left here? So I factored the x plus 2 out, so it went away. So what's still left? That 3. So 3 is going to be the first term here. And then out of this section, the minus x times x plus 2, I factored the x plus 2 out. So what's left? The minus x. Okay, so I know this looks pretty complex, but let's compare it back to the original. All I did was take the x plus 2, which both sections of this expression have in common. That was my GCF. I factored it out. And I was left with 3 minus x. That went inside the parentheses here. And you can actually see if I multiplied this back through, I would get back to this because I would be taking x plus 2 and I would multiply it by 3. So 3 times x plus 2. And then x plus 2 multiplying it times negative x. So that's negative x times x plus 2. So I do get back to the original. Now this just takes some practice, so don't get frustrated or give up yet. Just keep walking through this together with me. So let's look at some other ones. A times the quantity a minus 5 plus b times the quantity a minus 5. We can see that both of these have an a minus 5, right? I can go through, let's highlight that. Here's the a minus 5 here, here's an a minus 5 here. So that's what they have in common, okay? So we're going to go ahead and take that as our GCF. So that means that's what sits on the outside, a minus 5. Now there were two different sections, a times a minus 5 and then b times a minus 5. So in the parentheses here, I should have two different terms. So what's left over from this first section if I factor out the a minus 5? We would still have a. And what's left over from this section if I factor out the a minus 5? We still have the plus b. So this would be our final factored form. And it's a polynomial times a polynomial. That's why I know that it's a factored form. Part B, they both have an a minus b, so our GCF is going to be a minus b. Okay, and then what's left over? Well, if I factor out a minus b, what's still here? Well, out of this first section, the a minus b would be gone. I would still have an x. A minus b over here is gone. I would still have the plus 3, so it's x plus 3. Go ahead and try the next one on your own. Pause the video, see what you get, and then come back and check. So hopefully you saw that the GCF here would be x plus 2. So that means x plus 2 is on the outside, and what we still have left from each section, well, I took out the x plus 2 here, so I'm left with xy in the first section. I took out the x plus 2 over here, so I still have a plus b in the second section. 2 sections to start with. That's why there's 2 terms in this second set of parentheses. Okay, let's go ahead and keep going. Here, both have a 3 minus y. That makes it the GCF. So that sits out first, 3 minus y. What's left? We have 5x from the first section and plus 4 from the second. And the next one, both have an x minus 3. So we factor out the x minus 3. What's left in each section? 4y is in the first. And then over here, I don't see anything. So this is a little bit different. But think about that. If there's not a number actually there or a letter or anything, I know that that's a 1. So what am I actually left with here? I'm left with a plus 1. And I know I needed another term here because I started with 1, 2 sections. I need 2 different terms here in that second set of parentheses. One more. 2 minus x is common to both, so that's our GCF, 2 minus x. Factoring that out, we're left with 4x squared minus 3y. Okay. All right, so the next section gets just a little bit more complex because if I look at this, I see a 6x plus 3 here and a 2x plus 1. I see a w and a y. That means for each individual section, I don't see anything in common to those. However, if I look at 6x plus 3, I can see that they still have something in common, right? The 6 and the 3, if I just focused on 6x plus 3, if I said, hey, go ahead and factor this, we would be able to factor out a common factor of 3. And when I factor that out, we would be left with 2x plus 1. So let's replace this 6x plus 3 with this entire 3 times 2x plus 1. So I still have that w out front, so I still want to have the w, and that's going to get multiplied by the 3 2x plus 1. And that might look funny to you. You might want to rearrange it and say it's 3w times 2x plus 1. And then we still have the second part over here. So it's plus y times 2x plus 1. And that means that now this looks like one of the problems from previously that we're familiar with, right? 2 sections, they each have the 2x plus 1. So that's now our GCF. We factored 2x plus 1 out. And we're left with 3w plus y. So in the second set of parentheses, we have 3w plus y. So sometimes if a GCF isn't obvious at first, we have to do a little factoring to break it down so that then that GCF can be found in both sections. And so let's do the same thing over here. I have x squared plus x plus 4 times x plus 1. So here's our first section, and then here's our second section. X squared plus x is not completely factored, right? There's something in common to x squared and x. So let's just focus on that alone. X squared plus x. If I had you factor it, the GCF would be x. So we would factor an x out, and inside we would be left with x plus 1. So now this is actually the first section here that we can replace it with. So I rewrite the whole problem. It would be x times x plus 1 plus the second part, 4 times x plus 1. And now I can see that there truly is that common term here, that common binomial. And so our GCF is going to be x plus 1, right? That's what they each have. And what's left over is the x plus 4. So in the second set of parentheses is x plus 4. Okay, so I took something that was originally one section plus another section, and I've rewritten it as one polynomial times another polynomial. So that's why this is the actual factored form. Try the last one on your own. This one's a little bit more challenging, but see if you can figure it out. Pause the video and then come back. So hopefully you're looking at each individual section. So the 27x cubed minus 9x squared. If I just said, hey, look at that by itself, if I wanted you to factor out a GCF, I can see 27 and 9 have a 9 in common. X cubed and x squared, the GCF would be x squared. So 9x squared is the GCF out of this first section. And if I factor that out, I would be left with, well, my first term, 9x squared times what is 27x cubed? That would be 3x. And 9x squared times what is minus 9x squared? That would be minus 1. So this is that first section. So we could essentially replace this first section here with 9x squared times the quantity 3x minus 1. Unfortunately, I still don't see that over here in the second section. So for the 15x minus 5, I'm going to go ahead and factor that as well. 15x minus 5 has a GCF of 5, and if I factor that out, the first term would be 3x, and the second term would be minus 1. So 5 times the quantity 3x minus 1 could replace this second set of parentheses. And I'm subtracting them, so I just need to remember to write a minus sign in between these two things. So let's write it out. We would have 9x squared times 3x minus 1 minus, from this subtraction here, and the second part we can replace with 5, 3x minus 1. Now I can truly see what's common to each of these. They both have a 3x minus 1. So we want to factor that out. So we're going to take out 3x minus 1. And the terms that we have left over to fill in the second set of parentheses is 9x squared minus 5. This takes practice. So if you're still feeling a little shaky on it, don't worry. I'm going to help you out with it, but I want to see what you can come in with. So finish the rest of this worksheet on your own. Ask questions of each other as you have them, and then we'll go over it together as a class tomorrow.